because the second derivative is positive, which means W is concave up. And if you look at the graph, concave up and increasing, your tangent line is in under approximation. All right, C, finding our solution. So we're actually going to solve for W equals with the initial condition 0, 1400. This is just like the last one, separate, integrate, plus C, plug it in, solve for W. All right, so step 1, separate, multiply my dt over. I need to get this W term on this side, so I'm going to divide that over. Now I'm going to integrate both sides, so the antiderivative 1/25 dt is just 1/25 t plus c. And then antiderivative here, this is just on the bottom with the power of 1, so that's a natural log. This is going to be natural log of w minus 300. I need to plug in to get c, so I'm going to plug in this point. So this is natural log of 1400 minus 300 equals 1/25 of 0 plus c, that's just 0. 1400 minus 300 is 1100 equals c. Now I'm going to plug that in for my c. Okay, now I need to get w by itself, so I need to do raise to the e to the power on both sides. This cancels out, so that's just w minus 300, and this is e to the 1/25 t plus natural log of 1100. Now I can simplify this a little bit, so this is the same as e to the 1/25 t times e to the natural log of 100, because adding in your exponents is the same as these bases like multiplying by each other. This cancels out and it's just 1100, so this is the same as 1100 e to the 1/25 t. And then your last step is to add that 300 over, so w is 1100 e to the 1/25 t plus 300. And there's your solution. All right, and a couple just quick examples, because in your practice you will have a little bit of a trickier one. The other ones that I did, you didn't need to worry about any coefficients, but there is one with coefficients. So first of all, we know the antiderivative, the integral of 1 over x dx, that is just natural log of x plus c. This one, this is definitely looks like a natural log. We have 1 over, and it's not to any power. If it was something like 1 over x squared, then you would just say, oh, that's x in -2, add 1, divide by that power. That's very different than if it's to just the first power, and then I know this is natural log. This one is just going to be natural log of x minus 2 plus c. Now this one is different. It is going to be natural log of 2 minus x, but it is not just this, because think about if you were to take the derivative of this, you would say, oh, this is 1 over the 2 minus x, and then you would multiply, you would use chain rule and multiply by the derivative of minus x, which is times -1. Now you'll notice I don't have a -1 here, so that must mean you need to divide by the -1, which is just putting a -1 right there. Now, some of you, that made total sense here. You're like, yeah, the derivative of that is just 1 over x minus 2. Derivative of x is just 1, so no need to do anything. Here we had a negative. There must have been a negative. There's not, so there must be a negative to cancel that out. Now, if that didn't make sense, what you can do is you can use u substitution. Make 2 minus x your u. Du would be just negative dx. Get dx by itself, so divide the negative over. Then it would become 1 over u. Dx is just du over -1. So this is just -1 over u du. And the antiderivative of that is just natural log, and there's a negative out front. Very, very similar here. We know this is definitely antiderivative of, like, I'm going to get natural log. The natural log is going to be of the inside, the 2x minus 1. But we know that if we were to take this derivative, we'd be multiplying by derivative of the inside, which is times 2. There's not a times 2 here, so I must have a 1/2 that would cancel that out. Again, you can use u substitution. So if u is 2x minus 1, it's u. Du would be 2 dx. Divide the 2 over to get dx by itself. This would just be 1 over u du over 2, which is 1/2 antiderivative of 1 over u du, which is 1 over half natural log. Here, super similar. Still 1 over to the 1 power right here. So this is natural log of 1 minus 2x. But because the x has a coefficient, when we take the derivative, you know you will be multiplying by times -2. I don't have a times -2 here, so I must have a -1/2 out front. Again, u substitution will work. And then that's what we got here. But since these are pretty straightforward, all you're doing, like it's not a complex u substitution. Your du doesn't have like x's that need canceled out. It's just coefficients. Some of you are going to get to the point, hopefully most of you will get to the point where you're just like, yeah, that needs a 2, so there must have been a 1/2 out front, etc. All right, good luck with the rest of it. Just like I did here, right, you don't need to write out the whole question. You can just answer. Make sure you're showing your work. I will have, I guess, tutorials office hour times posted. And you can also just send me an email and I can hop on Google Hangouts if I'm free during like the 8 to 4-ish times on Monday and Tuesday. And yeah, let me know if you need help. Bye guys, good luck.